still solid, not moving. Yeah. So the weight is going to be equal to the buoyancy force. So the weight is going to be mass of the solid times gravity, and the buoyancy force, we saw that it was density of the fluid times gravity times volume of the solid. Can we apply the definition of density to the solid? Yes, we can. Every time we use this. Density is the relationship between mass and volume in this case. So we can apply to either fluid or solid. So if applied to solid, density of solid is the mass of the solid divided by the volume of the solid. So from this equation, similar as we can did before, the mass of the solid is also the density of the solid times the volume of the solid, right? So if I substitute this equation there, where it says now, so I can write density of the solid times volume of the solid, just substitute there, times gravity equal density of the fluid times gravity times volume of the solid. Okay? So these common factors, remember when we analyze equations, so we can remove in one, divide by g in both sides, so it's cancelled, right? And then you see the volume of the volume of the solid is common in both terms, so you can cancel it away. So what's the conclusion? If the solid is still solid, the conclusion is that the density of the solid is equal to the density of the fluid. This means it's still solid. Still solid. It's not moving. Why is this important? Yeah, because for instance, divers, scuba divers. If you try to float, you see that you float partially, in water. So your body is like this, and your legs fall, but you float. You float. So divers do want to go inside water. Yeah, but how? So they calculate to have the same density of water at some depth, for instance 10 meters. So how can you do this? How can you be exactly still at 10 meters? So they calculate the density of water, they calculate the body complexion, and they use leads in the belts, so their density is equal to the density of sea. So they are still. So if they are still, they jump to water and then they sink until this 10 meters, and then they remain there. So they don't have to swim upwards or downwards to, water is not taking them away, so they can swim horizontally. Fish do the same thing with their natatory bladders, okay? And our friend here in this point, when it's still, let me get it still, the density, is the same. The density of the little friend is equal to the density of water. Okay, how can I do it? Here what I do is when I press, water enters and it becomes more dense. That's our next situation. I already said it also to this car, but you see it comes naturally and very similar. So what happens if there is a imbalance, right? Balance of forces in the first case. Second case, it's time, 2 minutes. Second case is where the solid is sinking. Why? Because the weight dominates. Okay, the weight dominates. If the weight dominates, if weight is higher than buoyancy force, okay, the weight and the force, what happens? The solid sinks. what happens if we do all this reasonment again, but instead of with an equal, with a greater than, we will conclude that okay, so if the solid sinks, what happened? The density of the solid is higher than the density of the fluid. So if it's more dense, you will live, you become too dense, you will sink. And the third case is going up. Going up, if the buoyancy force dominates, is bigger than the weight. So going up, what will happen? The same idea, blah, 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 but now the weight is going to be less than the buoyancy force. So in this case, what will happen? All the rhythm will be the same, and the density of the solid is less than the density of the fluid. Time running out. So this is what happens with big ship. How can we have like a ship that weighs like a airship cruiser, or I don't know, I remember, airship carrier that weighs, I don't know, tens of thousands of tons, because it's less dense, because it's filled with air. So it's less than that. The density is less than water, that is roughly 1 gram per cubic centimeter, and then go up enough to float. Okay? Yeah, so this is only still going up and going down. We need to analyze a different case. How long do I have? I think that's enough. It doesn't say. Well, anyway, so we'll do it tomorrow. Bye.